Thank you, Candice. Super awesome to be here. Good to be with you, Michael. I know we had the pleasure to meet in person at KubeCon, and it feels like time flies. Here we are again on one of these webinars.
Absolutely.
Awesome. Yeah, I think Candice mentioned it in the introduction. You've embarked on this journey at Aussie Broadband. You know, tell us a little bit more about what's your role at Aussie, and why have you been kind of looking into bare metal Kubernetes in the first place?
Yeah, absolutely. So I'm the ISP platform manager and have come from a platform engineering role. Uh, we have been looking to, I suppose, drive down our infrastructure costs while improving our developer efficiency, improving our developer, um, improving our infrastructure resiliency as well. And moving to Kubernetes seems to have been the native way to do that. Uh, we've been rapidly growing. So another massive challenge we've had is scale really quick. Yeah, that's probably the briefest overview.
Yeah, it makes a lot of sense. I think everybody's been kind of embarking on the Kubernetes hype train, right? I can't believe that, it's been 10 years of Kubernetes. I know the celebration was last year. Such a long time already that Kubernetes has been making a footprint here. Yeah, when we embarked on the vCluster journey in, you know, 2021, obviously Kubernetes was around for quite some time, but we initially started actually from the developer experience as well, figuring out how can you hand over, more Kubernetes to more engineers in an organization without, breaking the bank and, causing all of these issues, or cramming folks into a single namespace that, typically is really not sufficient for a lot of things you want to do with, CRDs, Argo CD, all kinds of things require cluster-wide permissions, as you know, Michael, and probably a lot of folks here in the audience have had similar experiences. But your story is quite remarkable. I'll pull up the fact sheet here, right? This is this is a pretty crazy story. You had 195 VMs, and you went to zero ultimately in about a year. Um, Tell us how did your infrastructure look before you embarked on this journey?
Yeah, when I started at Aussie Broadband and prior to this journey even beginning, we had Kubernetes as a pipe dream. It was all virtual machines. Most container workloads were running Docker, and there was no orchestration of container workloads, right? The reliance was on VMware as the orchestrator. Um, or in replication, and then we have replicated workloads 2, 3x just to have that resiliency that we might get from one deployment in Kubernetes of 3 pods. So it was really not optimized. The platform was just not optimized at all for container workloads. From there was a desire from our development teams and our platform teams to move into Kubernetes. So what we found happen was VMs were what the platform team provided to internal teams. So virtual machine clusters were created, and they were created uh, per use case. They were created per team. There was no real consolidation or strategy there. They were just created as they were requested. And that led to a lot of challenges. Maintainability is probably the biggest one. Because we were running so many disaggregated forms of Kubernetes, maintaining the Kubernetes versions. Anyone that has run Kubernetes obviously knows that, hey, I want to deploy an app in 2025. I can't be running V1 alpha APIs from 2020. It's just not going to work. Or it might work, but some things might not deploy, and then deploying a standard Helm chart is not going to be easy for my developers. So that was probably the biggest challenge, was maintainability. The expense was also huge. We were running duplicate workloads, and not just duplication of applications, but duplication of what we consider an infrastructure service. So things like Cert Manager, things like Metal LB, things like our CNI. There were hundreds of these duplicated across all of our VMs. Security tooling. Obviously, every enterprise has a lot of security tooling, and this comes with a big cost. as you spin up 195 VMs or you spin up 800 VMs, that cost is quite linear. It doesn't go down. So we had a problem, and we needed to look at how we fix this. That's probably what it looked like, and what we were faced with.
Yeah, I think everybody can probably resonate with this journey. We see this cluster sprawl, right? Clusters popping up here and there, and more requests for clusters coming in. How did you spin up these clusters? Was it all, kube ADM, just kind of like hands down spinning up clusters, or was there a cluster API or any kind of mechanism behind it at least?
It was embarrassingly manual. Um, so we initially started with kubeadm, and that involved a systems engineer jumping in to these boxes, running kubeadm in it, and
Oh
spinning up
wow.
these clusters manually. Eventually, and massive credit to the developers behind it, we discovered Spray. We started using that, and driving everything through Ansible, which did become eventually quite efficient. But it wasn't quick. It was still a matter of potentially days by the time we actually spun up these clusters, spun up the VMs, and spun up the clusters on top. Ensured that they had met all the requirements, met CIS benchmarks, et cetera, all these things that have to happen. Yeah, it was not efficient at all. It was a quite a big journey.
Yeah, I've definitely seen my fair share of Cube Spray and a whole bunch of other automation tools out there. I think right now, probably more of the cluster managers and full-blown turnkey solutions are taking over at this point. And obviously the managed, cloud provider solutions in the public cloud are pretty predominant. But there is still a lot of clusters out there that are bootstrap, pulled together, kubeadm joining the nodes, right? Yeah, that was definitely the standard for years, to be honest. So it seems like Aussie was on the same track.
Yeah, and we loved it in a way. We loved being ahead of the curve. One big benefit of running vanilla Kubernetes is if I wanted to download the latest release that was pushed yesterday, I can.
Yeah.
The resiliency of my platform might not be so thrilled in the earlier days of Kubernetes, but obviously these days actually that's quite viable. Um, yeah, the other thing probably worth noting is we are all on-prem. So Aussie Broadband doesn't have any cloud presence for compute resources. We use software as a service and other things that might live on cloud platforms, but our core infrastructure is all on premises, all in our own data centers. So
That doesn't make
that
it any
that
easier.
yeah, it restricted us from doing some of the more industry standard ways using cloud providers.
100%. Yeah, it's definitely more challenging in those environments. And I think we've all seen, Kubernetes the hard way, right? Kelsey Hightower's legendary starting point for a lot of folks to learn how Kubernetes actually gets pulled together into a cluster. And it sounds like pretty much that was not just a learning experience for you, but the actual reality for managing Kubernetes for quite some time.
Yeah, absolutely.
So you embarked on this bare metal journey. Why did you decide, hey, we could get rid of virtual machines as a layer in our stack entirely and ultimately, explore the bare metal route?
So there's a few big reasons, and a few big shout outs potentially. vCluster, probably number one, KubeVirt, another big one. We had to look at the problems we faced on our VM clusters being they aren't maintainable, or reasonably with the staff that we had at the time. Um, they weren't consolidated. They weren't performant. And this is another big issue that we had was our infrastructure was designed for virtual machine-based workloads, purely running SanDisk, purely running 10 gig networking. Once you start to really scale out with Kubernetes-based workloads, a lot of the cracks started to show. Storage was probably our biggest one, and we would see when you are running I suppose, a distributed file system on top of a SAN disk, where we began to see a lot of write amplification. We began to see a lot of um, latency problems, and that was starting to hurt. So we needed to look at our solutions. We needed to look at whether we continue down the path of VM-based work or VM-based Kubernetes clusters and um, designing new infrastructure to run those. We looked at multiple. We looked at the requirements we had, and that was probably the big key to why we made the decisions that we did. And that was that we had multiple teams, multiple development teams, multiple infrastructure teams across our company that all wanted to consume Kubernetes. They all wanted to use it, but they didn't want to manage it. So we looked at consolidating those Kubernetes clusters into one or into two, and what that would look like, how we would isolate tenants, and we looked at all of the different solutions that could enable us to do this. So the very first that we did look at was probably the classic and probably something that everyone has ever done, and that is restricting each tenant into their own namespace, letting them deploy their workloads into one or more namespaces and relying on RBAC to allow them to isolate from other users. And that it credit where credit's due, it works. It's a lot of manual work to set up all of that RBAC. It's a lot of manual work to set up all of those network policies. Even using some of the management tools like Rancher still required a lot of platform engineering time to actually go in, design the infrastructure to do this. And we found it, I suppose the word is clunky. It wasn't a clean solution. It wasn't fitting the requirements that our users had. They were isolated to a single namespace. They couldn't go and deploy their own cert manager, for example, to manage a DNS server or domains in a DNS server that we didn't use. They were restricted to what they were allowed to do. So it was very apparent to us that they needed their own Kubernetes, but they didn't want to run their own Kubernetes. So we looked at still giving them their VM-based clusters and standardizing these through a tool. We looked at hosting control planes with tools like Kamaji, and there's massive viability in those solutions. But we still looked at the cost that these VMs were using, and it was really down to CNI and storage mostly, the duplication of those. And we thought, well, let's try bare metal, and we found the performance of sharing workloads on bare metal was understandably massively better than all of these VMs running across the same bare metal service. Yes, there might be less ability to spread because we are talking about a smaller number of physical servers rather than virtual servers. But nothing stopped us adding virtual machines in other data centers for resiliency or in AWS, GCP, whatever, to be able to span that across, right? So that was what we wanted. What we didn't have was a solution that allowed us to do that until we discovered vCluster. It gave us the ability to use our bare metal Kubernetes cluster or one or more bare metal Kubernetes clusters to deploy tenanted isolated workloads. But it also gave us the big key of tenant isolation through the RBAC, the network policy that is all done for you. It gave us the key of their own Kubernetes cluster. So it was a bit of the best of both worlds between namespaces and VM-based clusters in that regard. But it gave us maintainability. And maintainability for a small platform team was game-changing. No longer did we have to manually go and set up AWS or Ansible playbooks to update Kubernetes clusters, monitor that, see how it's going. We could empower our developers to press a button, make an API call, type a CLI command, and their clusters are all up to date. They are all up to date with either features that we are adding in templates, or they're up to date for Kubernetes versions. It really gave us the ability to just empower developers and increase their velocity, really, in deploying workloads. Yeah, that was probably the real key there towards making that decision.
Yeah, I'm glad you got all these results. I think that's initially why we started the vCluster project to enable autonomy for engineers while at the same time, you know, making the CFO and everybody on that side of the house happy, because obviously you see the consolidation, less waste, and we see it here on the slide, 1,000 CPU cores, a terabyte of memory. That is pretty significant. I think at that scale, that is considerable, dollar amounts you're probably saving on top of, obviously saving that entire, VMware layer and the associated, license costs, which we all know has exploded quite a bit over the past
Well, and
year or
that was
two.
probably the other driver, right? VMware costs had increased. We were looking at, well, what does it cost to pay for whether a COTS solution that allows us to do this or build our own versus just VMware licensing costs. And we found that there were significant savings to be had there. One thing that's not noted on that slide is storage costs as well.
Mm.
Yes, a lot of storage arrays do look at reducing a lot of those base components of multiple VMs, such as the kernel. Um, but running 195 VMs is not free in terms of storage. They have to live somewhere. So consolidating that down to one copy of all of those base OS layers was a huge storage cost as well, a huge storage saving as well.
That makes a lot of sense. I think we gotta extend this slide, make it even more impressive
Yeah.
of the work you've done here. So let's recap this. So initially, your infrastructure looked somewhat like this. You essentially had multiple physical servers, then you had these 195 virtual machines spun up on top of this. They consumed a certain amount of, CPU, memory, storage themselves just for the that overlay essentially. And then you formed Kubernetes clusters out of these virtual machines. And then the new architecture looks more like this. You essentially have physical servers pooled into a single Kubernetes cluster. And then you spin up virtual clusters, which give you, a certified Kubernetes distro, an API that feels like you got a full-blown cluster all to yourself, but effectively you're running in a more multi-tenant fashion in a shared cluster.
Yeah, exactly. And I think our users not having to manage their own CSI, their own CNI, and being able to share things like Prometheus, like Cert Manager, like external DNS coming from the host cluster has been a huge time save and a huge OpEx save, I suppose.
That makes a lot of sense. To clarify for everybody who's not as familiar with the vCluster architecture, a vCluster essentially runs as a pod inside a namespace of a larger underlying, we call it host cluster. And it syncs pods from the virtual cluster's etcd context into the context, the etcd of the underlying cluster. So it can consume certain things of the underlying cluster. As Michael said, it can, for example, live in the same networking, it can consume the same storage classes. So you effectively have all of these things running once in the underlying cluster, and then the virtual clusters consume it through that underlying host cluster effectively. Awesome. And yeah, I think that's obviously a pretty exciting journey. How long does it take today to turn around the cluster, hand it out to an engineer? You were saying previously, there are custom Ansible playbooks, there's manual work involved, right? Even before that, it was more like, kubeadm joining nodes, SSHing into nodes. How's the difference been in terms of delivery?
So in terms of delivering Kubernetes clusters to those wanting to consume it, we've gone from days or minutes to I think it's 45 seconds to spin up a virtual cluster. The last I checked. Um, on top of that, there's no handholding. So they are entirely empowered rather than going to raise a ticket to the platform team or look into an IDP and request a workflow run. Um, they are fully empowered to just go and deploy a preset template, and we have them all as t-shirt sizes with different features. So one might have requests that are more suited to running virtual machines. One might have requests that are more suited to running a tiny workload or large workloads or large databases even. Um, but they have full power to do that themselves. I often log into our platforms that give us an overview or our observability platforms and see a bunch of new Kubernetes clusters that are sitting there, and I have no idea that they're there, but they seem to be running. They seem to be holding production workloads, and yeah, they have a lot of autonomy, but autonomy with guardrails, and that's been fantastic for us. Really increases both our productivity as well as our tenants' productivity.
That's awesome. Do you set any limits on how many clusters someone in the company can create, or is it really all you can take
Yeah,
up in terms of resources?
so I suppose that probably brings me into one of our main use cases, and that is ephemeral vClusters and CI/CD pipelines. So often when our developers are building containerized apps, they don't want to have a single Kubernetes cluster that they deploy onto, delete the app, deploy onto, delete the app. Using vCluster, they're able to deploy, test, to send it to UAT even, and then destroy that vCluster. And that can be done manually, but it can also be done purely within a CI/CD pipeline. Now, of course, having the ability to persist those persist those test runs means that when you have 20, 30 developers all wanting to test their own branch, suddenly we get a lot of clusters building up. So yes, we restrict them on a not necessarily on a per v cluster limit. They can spin up as many as they like, but we restrict them on the resources that they're able to use. So they might only have an allocation of n CPU, n memory, both at the template level, but also at the project level. So their cluster can only be a certain size, but their overall allocation of how many clusters of that size or how many CPUs, memory, storage, even things like load balancers, anything that you could put in a resource request or resource limit. Sorry, I forgot the resource name there to restrict something, but yeah, anything you can put in there, it will we can limit on. So
When
that's
you're
how we
saying per
restrict them.
project, are you referring to the project Notion in the vCluster platform?
Both. So it could be a project in the vCluster platform, and that's what we use as that abstraction towards an individual project that might be ran by a project manager and have all of these resources. If they have the requirements within a project like that to spin up vClusters and test workloads, we will create them a tenant or a project in the vCluster platform, specifically for that use case, and say you can use 128 CPUs and 2 TB of memory, but nothing beyond that.
Got it. So you're setting essentially these quotas, right? Depending on
Yeah,
groups of tenants that work on similar things, and that defines a project for you.
exactly. Yeah.
Awesome. I think we have a glimpse a little bit on the details on your, prior environment and how it looked.
Yeah.
I think we see it here on the architecture diagram. You were running RKE2. Is that still the case? Is that still making up your host cluster today?
Yeah, we are still primarily RKE2 as our Kubernetes flavor of choice. There are a few reasons behind that, but yes, that's the current choice. The old choice uh, was originally kubeadm, as I mentioned. Eventually, we transitioned into using RKE2 to leverage some of the automation features of Elemental and Rancher itself. But yeah, we are still using RKE2 on the physical layer.
Got it. And you mentioned earlier you evaluated Rancher projects, right? Or Rancher namespaces. And was that as part
Yep.
of Rancher projects ultimately?
Yeah. And listen, it was fantastic for tenant or not for tenanting out. It was fantastic for sectioning out a Kubernetes cluster to different purposes. And that's where we saw a real good use case for it. And a use case for adding some of our V clusters into Rancher to do that. But in terms of tenanting workloads, it was missing, I think, a lot of those core isolation features that we can put into our templates. And that might be things like setting a default runtime class, setting default network policies on a vCluster, syncing different resources to and from the host cluster. Those things just gave vCluster a massive edge in that.
That makes a lot of sense. Yeah. Are you using the vCluster integration for Rancher by any chance?
We are, yeah. So primarily from a platform team, I don't think our developers are using it at this stage. But we use it we might spin up a vCluster that has a few different purposes, and we might section off different namespaces within that vCluster through Rancher.
Oh, I see. Got it, got it. For everybody's context, what the integration does, it ultimately adds vClusters back into Rancher as a control plane so that you can use a vCluster just like any other cluster you would have managed by Rancher. And that gives you obviously the power of, Rancher's app store and some of the management capabilities around clusters, probably monitoring, investigation of workloads, a whole bunch of other things that obviously Rancher is great at for administrators of fleets of clusters. Great. I think we have a question here, and it's a little bit on the slide as well. etcd resiliency and disaster recovery. There's a question here, and I can pull it up here. How does the rest of the pool keep going ahead when some of the tenants nodes are facing issues? Obviously, you have one large cluster now that improves, efficiency. It reduces resources, but does it create challenges regarding the resilience of the underlying host cluster, right? What do you do if nodes fail, if there's issues with a particular vCluster? Does it affect other vClusters? Have you had any of these challenges?
Yeah, I mean, anyone that does run multi-tenanted Kubernetes clusters knows that. I suppose I'll address this in two parts. So the first is, does a vCluster impact other running vClusters on that node if it impacts that node? And I suppose the short answer would be yes, that it can. Um, and noisy neighbor can be a huge problem here. Um, we have in place some strategies, and a lot of those strategies are around limiting disk I/O per storage class that we allow into a vCluster, limiting the requests, so really heavily using requests in Kubernetes to limit how many requests an individual vCluster can set. Um, but it can still be a problem. And looking at different solutions that are upcoming, and I think we have a couple of slides on vNodes coming up as well, right, Lukas? There are solutions that are being built or do exist already that really help address that issue of noisy neighbors on a single host. The other part of the question, I suppose, was if a node were to fail, how does that impact the vCluster? So it can be a problem depending on how we've architected the vCluster or what template the vCluster uses. So for some of our ephemeral vClusters, they don't run in what we'd consider HA mode. They run a single etcd pod and API server pod. Now, if the node that is sitting on fails, yes, the cluster is going to go down. Now, being a Kubernetes workload, being replicated at our storage layer, it just spins up on another node, right? So there is a downtime period, but it does come back up. For any of our critical vClusters, for things that are hosting databases, hosting virtual machines that might be really critical to business continuity, we run those in HA mode. So same as you would run a HA Kubernetes control plane, there are 3, 5, 7, generally 3 replicas of both the API of the entire control plane. So API server, etcd, what else is vCluster on? The controller manager, and core DNS. Those are replicated across zones or replicated across different infrastructure types within either a data center or in the situation which we are currently in. I suppose this slide doesn't really represent it very well, but we are spanned across data centers for our Kubernetes cluster. So We might have a replica of that control plane in data center A, B, and C. So yes, workloads will go down as any workload will go down when a node fails. But as long as that control plane is up, they will reschedule, or if they're designed for resiliency, they'll keep running.
That makes a lot of sense. Thanks for all the details, and thank you, Hari Sankar, for the question. It's
Yeah,
obviously a
thanks for the
very
question.
good question. Something that, people sometimes they embark on a journey and they don't necessarily think from the start of all the failover scenarios. I know your team has spent quite some time on making sure the platform is up and running for tenants, and uh, also thinking of strategies to mitigate certain scenarios. I think one of the interesting cases here was obviously, potentially splitting up where vCluster control plane runs versus the actual tenant workloads. I think we had that conversation with your team very recently as one strategy to eliminate some of the challenges. And it has generally been a best practice in Kubernetes to have, master nodes separated from the actual workers. And I think a
Yep.
similar pattern can apply for vCluster in some instances.
Yeah, and that's I won't say our infrastructure is in the perfect state at the moment. I'm not sure anyone could say that. If you can, please, we are hiring. Let me know. So,
Yeah, tell us the tips and tricks. Put them in the
yeah.
comments.
So yeah, one thing that we faced was noisy neighbors on, particularly on IO, and that came down to, hey, we are running all of these, Postgres databases, web servers, whatever else we have in Kubernetes, caches, things like Redis, Dragonfly, KeyDB, whatever it's called at the moment. Sorry to anyone who uses that product. Um, so we have all of these workloads, and they were running side by side with the vCluster etcd. So that can be a bit of a noisy neighbor problem, and we did begin to see that. Luckily, we do have fairly decent observability, so we could see, um, latency time in etcd beginning to increase. So one strategy, as Lukas pointed out, that we were recently discussing at the moment, or recently discussing, was we are dedicating certain nodes in each zone just to the etcd or just to the vCluster control planes. So we taint these nodes. The vCluster control plane has a toleration, and it spins up only on those nodes, along with anything else that might be required, CNI, CSI, etc.
And as far as I know, you've been using the embedded etcd feature in vCluster. That's correct, right?
Yeah. Yeah, I don't know how you did it, but by using, and props to your development team there, Lukas. But I think we saw about a 2 to 3 millisecond average P99 F-sync decrease in all of our etcds by moving to the embedded etcd. So that was fantastic to see.
That's awesome. Yeah, I think embedded etcd for everybody's context is one of these things we developed in vCluster because when you spin up a virtual cluster or any Kubernetes control plane, what you typically need is some kind of data store, right? You've got to persist the state of that Kubernetes cluster. And, historically, that obviously requires to spin up full-blown etcd cluster. And, if you're thinking about, doing something like Michael did with, hundreds of virtual clusters, it may not be fun to run hundreds of etcd clusters and all of them requiring 3 pods. And then you also run your control plane components, API server, controller manager, you want to run them in HA mode as well. You end up with a lot of pods in your cluster. So one of the things we did in vCluster is we tried to bake everything into a single pod. That means you have the control plane components, API server, controller manager, the syncer, which is kind of our alternative to the scheduler, or potentially also a scheduler. We also have a mode to directly enable a scheduler, plus etcd in one single pod, and even actually core DNS as well. There's also the option to do embedded core DNS. Are you doing that as well, Michael?
We're not. Um,
Okay.
yeah, not core DNS, but that's because we are doing, I suppose, some unholy things with core DNS. Probably the best way to say it.
Understood. Yeah, I think
Limit that
core
blast
DNS is
radius, so to
probably
speak. Yeah.
I see. I think core DNS is probably also more on the lighter end of components.
Yeah.
So maybe a little bit easier to actually run that as a separate pod than an etcd cluster. But yeah, the way it essentially works is you start out with, a single pod that has your control plane plus one replica of an etcd cluster. And then if you want to scale your etcd to an HA etcd plus have your control plane scale to, an HA control plane, you essentially just set the replica number to 3. And there you go. You got 3 vCluster pods, and you have an HA vCluster plus HA etcd cluster, which obviously gives you a pretty, decent amount of resilience. And I think you faced issues as well where one, etcd replica was getting out of sync because of these I/O issues, but the other two were still running, and your cluster is still responsive and can take over in these kind of scenarios. That's correct, right?
Yeah, absolutely. That was a big issue we faced. And I think it came down to us using the wrong technology for storage to run 50, 60 etcd clusters. But yeah, that was one of the early issues we absolutely faced. We like to think, I suppose this is probably a bit of an analogy that we like to say internally there, Lucas. But the way we're seeing, I suppose, the embedded pod of vCluster, which runs everything, is it's a traditional Kubernetes control plane without the VM overhead, right? Exactly what I would have been running on one of my kubeadm masters. It's running all of those components. It's running them a lot lighter.
Yeah, but I think that's a good analogy to use here. I think we have this diagram as well. It may be a little hard to see for folks here. It's quite small, but Michael, tell us a little bit more about the in-depth architecture here. Anything to point out?
Yeah, so this is, I suppose, I would call it a high-level diagram, as much as project managers may disagree with me. Um, this is what our infrastructure is currently moving towards. So at the moment, we are spanning Kubernetes clusters across data centers. And while that allows us to make individual vClusters resilient, individual clusters resilient to data center failure, um, it's not necessarily worth the cost for us to do that. Data centers and most data center providers that we are within have crazy SLAs, right? I don't think we've experienced one data center failure ever. So we looked at, well, what's it costing us to run this architecture versus what would it cost us to run a Kubernetes cluster per rack or a Kubernetes cluster per data center? And that's what we ended up landing on was we will run our infrastructure across numerous data centers, and I think it's going to be 20 or so data centers in the next couple of years for this particular architecture. Each one of those runs a physical Kubernetes cluster. The vCluster platform points to each cluster as an isolated cluster and can spin up vClusters on top of each of those. Now, the downside of doing that is that suddenly and 4 or 5 years ago, I would have said, well, the downside here is that these vClusters aren't able to run one workload across multiple clusters, or they aren't able to communicate microservice in cluster A with microservice in cluster B. But we're in 2025 now. Technologies like Istio have come a very long way, and the benefit in resiliency, the benefit of performance of doing it this way, and particularly in terms of network performance, yes, we have 100 gig everywhere, but it might be 20, 30 milliseconds of latency from one data center to another. That's simply by virtue of the size of the country I live in, right? So, and some of our international workloads as well, which we start to look at hundreds of milliseconds. etcd is not such a fan of that, but running something at the network layer and running etcd in one data center and just spanning the workload instead is a much better architecture, we think. The other benefit here is we still have that consolidated approach for our developers. They are still able to talk to a single pane of glass in the vCluster platform and manage all of their workloads across the country, across state lines, across country lines even. And yeah, everything is, see, it's not in place as yet, But we're in UAT testing for this architecture, and everything's going really well.
Awesome. Yeah, I think I've seen that pattern quite a bit as well, where people actually limit the blast radius
Yeah.
to the data center rather than trying to do like multi-zonal cross data center replication. Because yeah, as you mentioned, it is quite complex, creates a lot of expense, not just in terms of networking, network traffic, but also in general maintenance and operations across those boundaries. It's quite tricky. Even I think in the public cloud, multi-region Kubernetes spanning cloud provider regions is I am not even sure if that's possible in majority of cloud providers. And yes, I think that there was this one incident where a data center I think blew up and burned down in flames somewhere in Europe. I've heard that story a
Yeah.
couple of years ago. I think we've all seen that, but that's a pretty rare incident. And even in that case, I hope there were some backups. Hopefully, were
Yeah,
stored in a different location.
absolutely. Oh, they would have quickly learned if there weren't, I'm sure.
Yeah, yeah. I think that cloud provider is still around, so I'm pretty sure they had backups and were able to roll back and spin things up. And yeah, disaster recovery is obviously a pretty important feature here. We recently added vCluster snapshots as well, similar to how you can take a snapshot of a virtual machine. That was kind of the analogy, right? Take a snapshot, restore, roll back, potentially migrate from one cluster to another cluster. These kind of scenarios become very interesting. Have you played with this at all, Michael?
So we've primarily used it for migrating test V clusters onto this new architecture.
Oh, cool.
We thankfully, fingers crossed, haven't used it for a DR situation yet.
Yeah, always test your backups, I heard, right? There are definitely some folks out there that have a ton of backups, but unless you test if you can restore them, do you really have a backup?
Exactly. Automated backup restoration, or they don't exist, right?
Yeah, absolutely. I do have one slide here on maybe we can go out of here real quick. 1 second. I think I added one slide over here. Because you mentioned it earlier, I think isolation at the runtime and keeping things separate at the node. We announced vNode at KubeCon Europe in London. I know you're not using this quite yet, Michael, but you mentioned earlier that this was obviously a concern for you. So vCluster isolates things on the control plane, keeps your objects in separate etcds. But how do you do things on the node level? How do you keep tenants separate and limited and isolated? I don't think you're necessarily having malicious actors or outside workloads running in your cluster. So it seems like friendly tenant workloads, hopefully within your company. But you still probably want to, for resilience reasons, make sure that folks can't, break out of the boundaries on that particular node. How do you do this today? And, what challenges did you see there?
So I suppose gvisor is probably our biggest use case today of doing that, and a fantastic technology, but it's not perfect, of course. We don't necessarily want to run every workload under gvisor. It doesn't necessarily give us granularity of control over a project or over a namespace. It's all very individual, um, but it works. That being said, we've seen some downsides because actually facilitating making that a default runtime class comes with a lot of challenges, right? And that's one of the areas where we looked at. It's one of the areas we are currently looking at as a problem that we have and a problem we are looking to solve. And I know when you announced vNode at KubeCon, we went, oh, this might actually solve exactly what we're looking for. But it was always a concern, right? We're isolating tenants via RBAC, we're isolating tenants via network. There's still kernel isolation that needs to happen. Um, we see CVEs happen all the time for container escapes, even hopefully no virtual machine escapes, but container escapes do happen. Um, so I think a solution like this is needed in any multi-tenanted um, Kubernetes cluster.
That makes a lot of sense. Yeah. I think there were some minor limitations on gvisor with port forwarding. I think I remember was one, right?
Yep.
Yeah, that doesn't really work. I think it's kind of interesting to look at something so fundamental, right? And you're like, why is this not working? But yeah, I think the interesting approach. So gvisor with seccomp filtering predominantly as kind of the isolation layer can only do so much and definitely has its limitations. And it was quite interesting. We've seen a bunch of our users in the community work with vCluster and try to combine it with things like Kata containers, which again is VMs again, and then try things like gvisor, seccomp filtering. Um, and yeah, I think for us, we saw obviously username spaces as something really interesting, and the Sysbox project, which I think is unfortunately not as maintained anymore. I think they have some kind of like run C version and things like that that is like 3 years old and not really been updated. Which is obviously not something you want to bank on as a security product here, but um, we thought that approach of username spaces should really make its way more closer to Kubernetes. And I'm very excited to see that, user namespace is now a beta feature in the latest Kubernetes version, enabled by default, really easy to consume in Kubernetes. Is something that is front and center in Kube world today. But what we try to do with vNode is essentially not put tenant workloads directly run it in a user namespace, but actually have the secure container around it so that we can do things like emulate, procfs, sysfs, do seccomp filtering on top of the user namespace and do a bunch of other things to limit the tenant in there. I think really the combination of all of these things is probably what gets us a lot of security that we're trying to do on the runtime layer with vNode. So yeah, can't wait until you get your hands on it, Michael. I know this has been on your list, but we may have to wait. I think the list is pretty long, so we may have to wait a couple more
A-
weeks till you get to it.
Absolutely. We are very, very excited to play around with it. So
Awesome. While we're seeing this question here, I'm seeing anything like vpod and vcontainer in the pipeline. Yeah, I guess that would be the next layer, right? There's more V products in the making, hopefully. I don't think we're going to build a vpod. We do have devpod though, which is developer tool on top. So if you cross out the DE, I think you're you're gonna get there. But no, jokes aside, I don't think there's any V containers and V pods in the making. vCluster and
so
vNode will probably keep us busy for quite some
it does sound like a great marketing opportunity for you, Lucas. They're containers in
time.
containers.
Yeah, that's true. I heard some founders really like, the letter X and try to name everything like that. Maybe we should start the same with V. Yeah, maybe we don't, maybe we're not looking for those kind of associations though. I have another question here from a community member. Oh, it's Harisanka again. Um, did the standard single infrastructure and kind of standardizing specification here help simplify the procurement of things? How did that, feel in your organization?
As in standardizing what our infrastructure looked like, yeah, absolutely. I think it goes without saying, just any standardization will improve efficiency, will definitely help, um, definitely help procuring, I suppose, infrastructure itself. Like it makes it a lot easier to work with vendors. In terms of the efficiency of our spec, going NVMe and 100 gig as everywhere, um, that I mean, the performance impact we felt, or the performance, not impact, but I suppose it was impactful in a positive way, was insane. Anyone that has been in this space for a long time of just computing, it felt like I was moving from a Pentium 2 into, a modern Ryzen 9 or EPIC processor, just the snappiness of everything.
Yeah, makes a lot of sense. Um, yeah, I think you were on this consolidation journey Any advice for anyone else who is looking to do the same going forward?
Yeah. I mean, the biggest advice is keep it simple. One thing and one trap that we absolutely fell into early in the journey was trying to over-engineer. And that was trying to over-engineer the fundamental things like virtual machines, like the storage. Um, we were looking at this the wrong way, I think. And I think when you are dealing with a, a massive product or a massive project like Kubernetes, which is inherently so complex, it has so many different aspects to it. There are so many different things that you need to be aware of, right? So many things you can jump into and start fiddling with all those little knobs in etcd and controller manager and kubelet, right? Um, it needs to be on something rock solid. It needs to have an underlying infrastructure layer that is absolutely proven and solid. So keep that simple. Um, test and test and test. Uh, that's probably my biggest point of advice there. Um, the other thing I'd probably say is don't forget to capacity plan. It doesn't matter if you are running VMs. It doesn't matter if you are running vClusters. It doesn't matter if you are running Bare Metal Kubernetes and you are the only tenant and you are a small business, right? Um, it is always important to look at what things are going to be 3, 5 years down the line because Kubernetes does not like getting overloaded. Um, any infrastructure, right? Even VMware, even Proxmox, KVM, um, none of these like having or being limited on resources. Uh, don't run your infrastructure above 80%. Now,
That
obviously
makes
financial challenges, but yeah, where possible.
Yeah, that makes a lot of sense. I think having some infrastructure reserved for the spikes definitely helps.
Yeah,
If you run at 100% capacity, it's probably about time to order some new hardware, right?
exactly, exactly. Even if it's eBaying something old to just give you that breathing room, right?
Yeah.
Yeah, actually, I suppose the other thing worth saying is don't be afraid to ask what your devs want, what your internal teams want. Um, these guys often might not necessarily tell you that they want to be empowered and do it. They might just say, "No, I just want something click and serve." One thing we found was that once we gave them the power to do something else, they never wanted to move back. But once we gave them the ability to spin it up themselves, they wanted to manage that. They didn't want to manage underlying infrastructure pieces, of course, but what they did have control over, taking that away would be impossible these days.
Yeah, that makes total sense to me. I think if you tasted the freedom once, right, you
Yeah,
probably take it's a hard time to take a step back and say, oh, I'm restricted to this namespace. I can't deploy, these temp
yeah.
charts that have CRDs anymore. Yeah, there's probably that would probably be quite some change for engineering workflows here. How you're preparing, you mentioned, looking ahead and not just in terms of procuring new hardware, but how you're preparing for future workloads. I know there's been a lot of talk about AI, LLMs, these kinds of topics. Um, how are you thinking about that? Are you procuring GPUs? Is that something you're looking into? What's the journey ahead in that direction?
Yeah, it's something that's been looked into with the new infrastructure that we purchased. And again, because we are all on-prem, we quite deliberately overspec some of these machines in terms of the hardware footprint so that were we to slot GPUs into them, were we to slot large amounts of compute into singular nodes or dedicated nodes, we have the freedom and ability to do that. But everyone knows that AI is on the radar for everyone and has been for a couple of years. We are no exception. We have a lot of things in the pipeline that are being looked at, that are being considered, and this infrastructure is really at the core of that, right? The isolation is absolutely key, especially when we're talking about divvying up GPU to different use cases or different workloads, as well as preventing noisy neighbors on those GPU workers or even workers consuming GPUs. Um, and that's where I think we're particularly excited about looking at how vNode can sort of help us split those up. But yeah, it's something that we are looking at. It's something that we are it is at the forefront of all of the all of the platform engineers here and looking at is our infrastructure ready? Is this new set of infrastructure ready? And it was built with that in mind. Um, yeah,
That's awesome. Yeah, we made sure that vNode is compatible with NVIDIA GPU operator and all these kinds of things because yeah, we some of you may know that vCluster has been heavily used on GPUs, so it was a priority for us to optimize vNode for that spec as well. There's obviously been a lot of traction in that direction, and yeah, when we're talking about bare metal, right? GPUs, you kind of don't want that VM layer on top. It's such expensive hardware. You want to get the most out of it, and you want to squeeze every little bit of performance out of it as you can. And things are evolving so quickly, so you may want to as well skip that additional overhead and complexity and yet another thing to update in your stack and just run directly on the bare metal infra for GPUs. I think that's been a top priority for a lot of folks we speak with. So yeah, it makes sense. You got the infrastructure ready for it, Michael. Now it's time
yeah,
to plug in some GPUs and give it a spin. Definitely let us know when you get to that point. I know we're heading up on time here. I did want to pull up this last slide for anyone who has additional questions. I know we'll be around for another minute or two. But if you have additional questions about vCluster, we have a community Slack channel. So reach out at slack.vcluster.com. You can obviously, schedule a demo with us if you're more interested in the enterprise version and some support, or have questions around your architecture, or want to talk to our architects about potential design patterns and what to choose. But yeah, I think that was a great webinar here, Michael. Thank you so much for going so deep on all of these topics. I think the audience took a lot away from this, hopefully. And yeah, maybe they can reach out to you as well. I'm not sure what the best way is to find you. Probably, I don't know, LinkedIn or something
LinkedIn.
like that.
Yeah,
Yeah.
always open to questions.
Awesome, great. And yeah, Candice, you're probably still around. I hand it back over to you. I'm not sure if we still have a minute if there are any other questions.
Yeah, we can give it like a minute if any other questions come through.
Yeah, I think we answered a bunch on the way. And that was great. I always love when people ask questions right on the slide, right
Yeah,
as part of the conversation. But yeah, hit us up on Slack. You'll find Michael and me on LinkedIn if you want to have more of a one-on-one conversation. But don't be shy on Slack. There's a whole bunch of engineers in there. I think there's like 4,000 other people in that Slack community. So just reach out, learn from other practitioners, and yeah, get in touch with any of us if you want to learn more about bare metal Kubernetes, ideally with vCluster.
Awesome. Well, thank you so much to Lucas and Michael for your time today. And thank you everyone for joining us. As a reminder, this recording will be on the Linux Foundation's YouTube page later today. We hope you join us for future webinars and have a wonderful day.